Hello world! Today we're going to be talking about classes in Python and how to use them in your code. Python is an object-oriented programming language, which means that all the programming is oriented towards objects. So the main idea of object-oriented programming is that you have data and functions encapsulated in an object, and only when you create instances of that object can you access that data and those functions. So in this video, we're going to be talking about some of the basics of object-oriented programming in Python. So let's just dive right into it. I don't quite have a desk yet, so I'm just be coding from the floor like this. Bear with me for a while. I just moved into a new apartment. The desk is on its way. So basically, when you create a new class, you're creating a new type of object. And you can define a class by using the class keyword like this. And so I went to the beach this morning. I'm going to create a beach class. So your code for the class would go underneath this class definition. And so basically you can define attributes of this class, and those are pieces of data that belong to the class. So for example, I can say location equals, and let's do Cape Cod. And technically that's really all you need in order to define a class. You actually don't even need this attribute at all. You could just pass and you would technically have a class. It wouldn't really hold much. But before we add some more complexity, let me just show you that we can actually create an instance of this class now. So here I'm going to do Cape Cod Beach. So this is my variable name equals. And in order to create a new object of the type beach, I need to call the class name beach and then add parentheses at the end. So this would give me a beach object and then assign it to the Cape Cod Beach variable. And then what I can actually do is I can access these attributes using a period like this. So if I print Cape Cod Beach dot location, this should actually print out Cape Cod because that's what we assigned this attribute in the class. So I'm just going to run that. Okay, so we see that it prints out Cape Cod. What we can actually do is we can then go into this instance and we can actually say, hey, this location, we're not in Cape Cod anymore. We're going to Cancun. So if I do that and then I reprint this location, let's see what happens. So we see that the first time it prints, after we create this object, this instance of the object, it prints out Cape Cod because that's what its default is set to. But then if we change it by changing the attribute like this, then we see that for this specific Cape Cod Beach, the location is now Cancun. And what's really cool is that here, if I say beach 2 equals another beach, I can print out beach 2 location. And then down here, after we change the Cape Cod Beach location to Cancun, let's also print out beach 2.location. So what we expect is here, both of these should be Cape Cod because we initialize both of these and the location, the default is set to Cape Cod. But then we're changing Cape Cod Beach.location to Cancun, which means that this Cape Cod Beach.location for this specific instance of beach is now Cancun, but that actually doesn't affect beach 2 because beach 2 is a whole new object that has its own attribute location, and it's currently set to the default, which is Cape Cod. So what we should actually see is up here, Cape Cod gets printed twice. And then down here, we should see Cancun and then Cape Cod. Okay, so just like I said, Cape Cod gets printed twice, and then we see Cancun, Cape Cod. Cool. So basically, when we create this new object, we're initializing an object. And typically in Python, when we create an object, you want more than just these like default attributes assigned to the object. What you'll typically see is an initialization function, and that looks something like this. So we have define underscore underscore init underscore underscore, and then within these parentheses, we need to include this parameter self. And self is basically saying, hey, within this class beach, any instance, then refer to that specific instance. Under most of our class functions, we'll actually see that we have the self as the first parameter for all of them. So when we initialize a function, we can go through some custom initializations in there. So let's say self.location equals, we're basically saying, hey, in order to locate that attribute, we need to call self dot. Just like how down here we did Cape Cod beach dot location, here it's self if you're within that function. We didn't need it up here because we didn't have like a function defined for it, but from anywhere else, if we want to refer to the attribute, we need a self dot. Okay, so now self.location equals, well, I don't want it to always be Cape Cod because there are beaches all over the world. So what I can actually do is then pass in location as a different parameter into this initialization function. So then I can do self.location equals location. So what this statement is doing is it's setting the location attribute of this beach instance that you are calling somewhere down here and setting that location attribute to this location that we've passed into the initialization function. So self.location equals location. Let's see what happens. Okay, Cape Cod beach, the location Cape Cod. And when we have this self, you don't actually pass in an argument into that. You kind of pretend that it's like not there when you call this function elsewhere. So down here, when I initialize beach, it goes through this initialization function, but we only have one parameter that we need to pass in because we kind of ignore self. And then down here, let's do Cancun beach equals beach, and then Cancun. Cool. So if we print Cape Cod beach location and then Cancun beach location, you'll see that we actually get Cape Cod and then Cancun. Okay, so we see Cape Cod and then we see Cancun. And so now we can also add more attributes. It doesn't just have to be location. So self dot watercolor maybe equals, let's pass that in as a parameter. And then let's also pass in temperature as a parameter. But instead of just temperature, and I'm gonna pass these in Fahrenheit, let's give it a heat rating. So self dot, we can set temperature equal to temperature, and then self dot heat rating can equal hot if temperature greater than 80 degrees Fahrenheit. Otherwise, it could be cool. Okay, so then when we initialize these, we'll have to pass in the rest of the parameters. So here I can make the watercolor dark blue, and then the temperature, let's do 70. It's a little chilly nowadays. And then Cancun, we can do watercolor crystal blue. And then the temperature maybe like 90. Sounds about right. So first let's print out the location, and then let's actually print out this heat rating, just so that we can kind of prove that this initialization function is doing something. Okay, so if we run that, Cape Cod first, so Cape Cod.location, Cape Cod, and the Cancun location is Cancun, and then the heat rating is cool, and then the heat rating for Cancun is hot. So already you can kind of see how these various objects have their own properties, but all of these are tied together by the same class. Okay, so earlier we saw that here we could also put in an attribute of the class that holds some data. And so here let's do something like parts. And of course we have water at a beach and we have sand at a beach. And this is called a class variable. Whereas these things down here, these are instance variables. So class variables are things that all the various instances of this object beach have in common, whereas these instance variables are more specific to each instance of the beach. And typically, if you think that an attribute might change, it's probably better to include it as an instance variable. So for example, maybe some beaches are just rocks and water. So then instead of this, we would want it down here. And maybe we have a different function that might alter the parts of the beach. Let's talk about creating functions in a class. And so here we can have the same function definition, def keyword. Let's do add part. And so here, of course, we need our self because we want to create a method that has access to the various properties of this one instance of the class. And then let's say part. Okay, so up here we have self.parts equals water and sand, and this is no longer a class variable. Under add part, what we can do is we can actually do self.parts.append part, and it can be literally that simple. So we have our Cape Cod beach and our Cancun beach. Okay, so let's use the Cape Cod one. So first we're gonna print the Cape, because I feel like Cape Cod beaches are a little rockier than Cancun beaches. So first we can print Cape Cod beach dot parts, and then let's do Cape Cod beach. And in order to call a method that's in a class, it basically works the same way as trying to access the attributes. We need this dot here, and then we just type in the function. And so here, this self is just referring to this, whatever precedes the period. So add part, and then the part that we want to add is rock, because Cape Cod can be a little rocky sometimes. And then let's reprint all of that, and let's run that. Okay, so you'll see that here in the first print statement, we have water and sand. And then after we add part and call this method in the class, now we suddenly have water, sand, and rock. And of course, you can actually create additional methods in the class. So these are the basic building blocks of classes in Python. Next video, I'll cover more advanced topics such as inheritance and polymorphism. But for now, this is what you need in order to start incorporating classes into your code. All right, now before we finish this video, I want to show you guys how to create a very simple script that actually uses classes. So here I'm going to define a main loop, and let's stick with these beaches up here, Cancun and Cape Cod. And basically what I'm going to have this main function do is just go through a bunch of beaches and see which ones have a heat rating of hot and do not have rocks in their parts. Let's add an LA beach on here, and this beach is an LA, and the watercolor, let's do turquoise, and let's say it's like 85. All right, so for beach in, and then we can actually create a list of these beach objects. So Cape Cod beach, Cancun beach, and LA beach. So for each of these beaches, if beach.heatRating is hot and beach.parts, let's say rock, not in beach.parts. Let's also do an Italy beach. Italy. And let's make this color blue. And let's say it's like 82 degrees in Italy. So for each of these beaches, we have to include our Italy beach in here. If the beach rating is hot and rock is not in beach parts, oh yeah, we need to Italy beach.add part rock. And so you don't actually have to have this like add part function. You could literally just pass in like parts here and then it could be a list. But for the sake of this example, I just have this as a method. So basically our Cape Cod beach is rocky and cool. Our Cancun beach is not rocky and hot. LA beach, not rocky and hot. And our Italy beach is rocky and hot. Which means that for all of these, it should return the Cancun beach and the LA beach because those are our hot, not rocky beaches. Hot, not rocky. And that's a new list. If it's hot and rock is not in beach parts, then hot, not rocky, we're gonna append that beach. And then at the very end, we're just gonna return hot, not rocky. Okay, if name, main, okay, so, well, we have to run this main function and let's do beaches equals that, print, let's do beach.location for beach in beaches. This right here is a list comprehension. Basically, it's saying, hey, create a new list, and for every single beach and beaches, put beach.location into that list. So right now we're printing a list of the beach locations. Okay, so let's run that. So we get Cancun and LA. And so that's basically a really quick example of how to use classes in your Python code. Thanks for joining me in this simple tutorial. Hope you enjoyed this class about classes. And next week we'll be back with inheritance and polymorphism, some more advanced topics that are still on the topic of classes. Woohoo!